However, we physicists say that the universe was created in a Big Bang 13.7 billion years ago. But then the question is, why did it bang?
Our preconceptions about the universe's origins might be off the mark, as indicated by recent findings from the James Webb Space Telescope. What if our understanding of the oldest galaxies and even the Big Bang required a significant reassessment? In 2022, an image from the telescope astounded the scientific community. Patches of reddish light and far-off galaxies that defy our previous understanding of the early universe. Numerous unexplained galaxies are challenging our perception of what we term the Dark Ages. Could we be standing at the edge of a scientific revolution? Let's find out. Maisie's galaxy, a recently uncovered celestial entity, was identified by astronomer Stephen Finkelstein from Austin, Texas. He bestowed the name Maisie's galaxy in honor of his daughter Maisie, as the discovery coincided with her birthday. Initially, the scientist and his team believed the galaxy originated shortly after the Big Bang. Initial distance measurements indicated an astonishing age exceeding 13.5 million years. They approximated that this galaxy came into existence a mere 290 million years post-Big Bang. However, a more complex analysis utilizing advanced equipment revealed it to be an additional 100 million years older than initially presumed. Maisie's galaxy was formally acknowledged as the oldest observed galaxy. Yet this newfound record holder couldn't maintain its status as the oldest observed galaxy for long. Currently, approximately 10 other galaxies under evaluation by CER's team may surpass Maisie's galaxy in age. If confirmations of galaxies existing even closer to the Big Bang emerge, the implications are beyond imagination. The temporal span between the Big Bang and the emergence of the first stars and star systems diminishes with each revelation from the James Webb Space Telescope. And this is just one of the telescope's discoveries in the years since its launch. Recently, it unveiled a previously suspected type of star called the dark star. The James Webb Telescope, which is playfully dubbed the mighty eye of NASA, is set to reshape our understanding of the cosmos. The JWST has identified 3 potential dark stars, which previously existed only as a theoretical concept. Dark stars are fueled by dark matter and paradoxically outshine other stars over a specific time frame. As we know, dark matter is believed to constitute the majority of the material universe, but eludes detection by conventional telescopes. Its presence is discernible only through gravitational effects or, put simply, the substantial weight that warps space-time. Dark matter is unseen and typically lightless. It possesses an unusually substantial weight, sparking interactions in space. In the realm of dark stars, the weight of this imperceptible mass can trigger processes leading to light emission. Much like the mass of a rapidly rotating dust disk that eventually compacts under its gravity, initiating a nuclear fusion process. Ordinary stars, such as our Sun, are propelled by regular matter. Dust and gases collide, swirl, and accelerate, making them denser and more massive. In contrast, dark stars draw energy from dark matter particles. This revelation is intriguing and may open the door to long-sought answers. If dark stars indeed exist, they could hold the key to comprehending the processes that generate light in the early universe. For approximately 15 years, scientists have postulated that dark stars played a role in the initial stellar formations of our universe. Initially, scientists estimated the timing of the first stellar evolution to be 700 million years after the Big Bang. However, galaxies are now emerging that existed a mere 300 million years after the Big Bang. The mystery of dark stars, if their existence holds true, might unveil the early existence of galaxies in the cosmos. Regarding dark stars, Webb's observations suggest that 3 distant objects possess all the essential characteristics of dark stars. These objects shine brightly, but remain too cool for fusion. The potential candidates for dark stars are Jade GSC 13-0, 12-0, and C11-0. Instead of being galaxies, these luminous objects might be enigmatic dark stars. To elucidate previously unexplained aspects in determining dark stars, Researchers are searching for deviations or surpluses in light intensity. Forecasts of dark star spectral types have yielded specific frequency band values typical of such a star. Employing analysis techniques, researchers are currently seeking these frequency bands in the light signatures of the three objects. However, this measuring method remains too uncertain to make definitive statements. Despite advancements in technology, making conclusive statements about objects so distant proves challenging. The quest for insights into phenomena at the edge of the temporal cosmos resembles a speculative endeavor. In the shadows of time, scientists can only rely on known values or those adhering to existing fundamental physical principles. Yet, it's essential to acknowledge that numerous quantities, forces, and unknowns exist beyond our current understanding. Here, the JWST introduces a new challenge for scientists in uncovering these cosmic mysteries. The abundance of galaxies in the early stages of the universe, surpassing the expectations of standard cosmic history models, raises inquiries. This discovery could unveil the genuine age of our universe, challenging certain scientific theories. Professor Gupta's perspective on the authentic age of the cosmos comes into play. Rajendra Gupta, a physics professor at the University of Ottawa, could gain global recognition if his innovative theory proves valid. Gupta was among the first to propose alternative scientific approaches that could elucidate the perplexing findings of the JWST. The mystery surrounding the seemingly implausible early galaxies might find resolution by approximately doubling the universe's age. Importantly, Gupta didn't merely adjust the timing of the Big Bang to accommodate these novel galaxies. His theory holds weight and stems from two modifications to established foundational assumptions. Previously, scientists gauged the universe's age by measuring the time since the Big Bang. The second modification involves scrutinizing the properties and physical behavior of the oldest cosmic entities. Until the APO of Hubble, these parameters were reasonably accurate, leaving some questions unanswered. Yet no cosmic anomalies emerged, such as the improbable galaxies or puzzling stars. To determine the age of distant celestial bodies, researchers rely on the phenomenon of redshift. As light journeys through space, it undergoes stretching, shifting its spectrum into the red region. The more distant an object, the older it is, and the more redshift waves become evident. Earlier, an estimate based on redshift and other factors pegged our universe at approximately 13.79%, the accepted standard model of cosmic evolutionary history at that time. However, Webb has entered the scene, bringing discoveries that challenge these standard models. An error in the red light shift was identified. Professor Gupta's work is grounded in a significant discovery from the 1920s by the relatively unknown astrophysicist Fritz Zwicky. Zwicky's tired light theory suggests that the redshift we observe doesn't only result from galaxies moving away from us. Instead, the red values could also arise because light loses energy during its journey through the universe. In essence, this challenges the assumption of an expanding universe, or the measurements may yield inaccurate values. Another physicist from the last century, Paul Dirac, proposed an intriguing but relatively unnoticed thesis. His research on coupling constants, governing fundamental physical principles related to particle motion and interactions, posited that these constants might have changed over time. This implies that particles behaved differently in the early cosmos than they do today. Such a shift could potentially explain why the galaxies revealed by Webb appear advanced in their evolution, and why previous assumptions about the cosmos and its fluctuations have struggled to offer definitive explanations. Are we still in the dark, or is enlightenment on the horizon? The current query revolves around whether scientists can formulate new universally valid models and theories based on contemporary observations. We might stand at a point where the path of scientific understanding diverges until clear evidence emerges. This evidence could include sightings of galaxies even more ancient than those captured in James Webb's initial deep field image. The telescope's reach is estimated at 13.5 billion years. Yet, throughout the operational life of the most advanced human-made telescope, we might extend our gaze even further back, uncovering additional clues about the universe's early stages. We might need to await the launch of an entirely new telescope or the discovery of fresh insights in light frequencies to address lingering questions. This situation should be regarded as a significant challenge. Scientists cannot cling to outdated theories and insist on their validity when the cosmos reveals something entirely different. Notably, some of the most profound questions about the universe remain unanswered. For instance, what precisely constitutes dark matter or dark energy? Where does our cosmos navigate, and does it possess an endpoint? Furthermore, did it ever have a beginning at all? We still must remain receptive to the notion that we exist in an infinite universe devoid of a defined start or finish. Despite the seeming coherence of the standard model of cosmology and the concept of the Big Bang, inquiries like what transpired in the initial moments after the Big Bang, or how the first elementary particles and atoms originated, remain unresolved. We would love to hear your thoughts in the comments below. Hit the thumbs up and subscribe button if you enjoyed the video.